We've got 15 to 20 to go. I'm going to start off with this fella. Nice simple one. Who knows, I may even have done it before. If you want to integrate a space curve, don't you just integrate each piece separately and you get a single answer? But when you integrate a space curve, isn't the answer a vector? Right, it's not 42. So in this case, you would do the integral from 0 to 2 of 8t. The integral from 0 to 2 negative t cubed. And the integral of 0 to 2 of 2t cubed. Okay, these are pretty easy. So that's 4t squared. 0 to 2. Negative 1/4 t to the 4. And 1/2 t to the 4. Okay, plug in that, you get 4, you get 16. Take away 0, so you get 16. Plug this one in, you get negative 4. Take away 0. Plug this one in, 8. And that's your answer. Are we cool with that? It's really just 3 integrations. I don't overthink it. You know, take each one totally separate and integrate it. And if it's got limits, you get numbers. And if it doesn't have limits, then you have an arbitrary constant C. So let's pick a version of that. This is essentially 16. You get a secant squared, a t squared plus 1, and a t cubed natural log of t dt. So far, so good. Right, now this one is not simple, so I'm actually just going to take 3 separate integrals. So I'll do this one first. This one's just a memory. You should hopefully remember what the integral of secant squared is. Don't shrug your shoulders, Emma. Come on. Secant squared. James, help her out. Come on, Sam. Somebody.
Tangent.
It is the tangent. And I'm going to put an arbitrary constant, which I'll call C1. And the second one is going to be t squared plus 1. Put a little bubble around that once I get the answer. Right. Okay, oops. That makes a big difference. What technique will I use for this one?
U sub.
Product.
Agreed. And the U sub is going to be t squared plus 1. And you differentiate with respect to t. You do the crossover. And then you isolate. What do we get? We get the integral of t, u is the 7, 1 over 2t du. The t's cancel, and we have that guy. We can then do a power rule. Add 1 to the power, divide by the new power. Convert the u back into t's. And add an arbitrary constant, but this time we'll call it C2. And that's us done. The second guy. That is not a U sub. Agreed? Calc 2, that is not U sub. That won't help you. I guess if that was t to the power of 4, you probably could have done a U sub, but it's not, so you can't. What's the method?
Integration by parts.
Right. Now in integration by parts, you have to pick an F and you have to pick a G, at least if you do it that way. Otherwise, you do it the UDV method, which works totally fine. Who shall you pick as the F and who shall you pick as the G this time?
Would the F be to T3? Or
Well, you tried. Most of the time, right? The vast majority of the time, that is exactly what you do. Isn't the F the power of T and the G is the other guy, right? But there is an exception to it, and this is the exception. When it's a log function, you make the F the log. Because there's a kind of rule in integration by parts is, if you can't integrate it, make it F. And we can't integrate a log, so we make it the F. Now, based on that then, the formula is it's F, big G, take away the integral of F dashed, big G, dt. Leave that alone and integrate this guy, so you'll get the log of t, and the integral of t cubed is that guy. Take away, if you differentiate a log, you get 1 over t, again multiplied by this fella. And then I just make it look pretty. One of these t's cancel, and we're looking at that guy. So 1 more power rule and we're done. Add 1 to the power, divide by the new power, and put in a C3. Okay. So what will your answer look like when you put all 3 pieces together? Well, the integral will equal this fella, tan t, this fella, 116 t squared plus 1 to the 8, and this ugly fella, now you notice I've missed out the C1, C2, C3, right? The plus C1, plus C2, plus C3. And that's because in WebAssign, they just call it plus vector C. So they've done it for you. They've actually got that written, so you don't even write it down. So you only need to write this bit, and the plus C is at the end. So if you look at the homework questions, you'll see it. And you know it's a vector because it's in bold. And so that guy there is essentially the C1, C2, C3 guy that was here, and here. So are we comfortable with the technique? If you can do Calc 2, you can do Calc 3, can't you? Because a space curve is just 3 integrals instead of 2, or 1, I should say. So what are the last questions that we still have to do in integration? They are puzzle questions. Something like this, perhaps. Find the original space curve, right? So find that guy when you are told who the derivative is. And you're told, now they're calling it I plus j. In fact, almost all these questions seem to be doing it that way. I don't like i's and j's, you know that already. So this and that are equivalent, right? Okay, how do you find the space curve when I tell you its derivative? What do you think you do? I think you said it, Emma, but I didn't hear it. Still can't hear you.
You integrate the derivative.
Yes, you do. So you integrate the derivative. So if you want to find this fella, don't you just integrate the derivative? So in this question, it's going to be the integral of 4t cubed, the integral of 7t to the 6, and the integral of t to the half, because I don't like square roots when you want to integrate something. Now you integrate this guy, you get t to the 4 plus an arbitrary constant. When you do this guy, you get t to the 7 plus a different arbitrary constant. Oh God, this is weird. Add 1 to the power, divide by the new power, right? Plus an arbitrary constant. So we are good. There's R of t. But there's some missing numbers. That's what this is for. Can you remember a Calc 2 question that might have said the velocity is this, you know, find the displacement function when s of 0 is 2. You know, the kind of one where you had velocity acceleration and you integrated. It's kind of like that. So what do I know? I know that R of 1 is 1, 1, 0. I also know if I plug in 1 here, I get 1 plus C1, 1 plus C2, and 2/3 plus C3. So I know R of 1 is this. I also know that it's that. And if you do a 1-for-1 match, doesn't that tell me C1 is 0? Doesn't that tell me C2 is 0? And what does this one tell me? What's C3 going to be? This 0 has to match this. What does C3 need to be for this to happen?
Negative 2/3.
You got it. So put all of that together and we now have the final answer. T4 plus nothing, comma. T7 plus nothing, comma. 2/3 t to the 3/2 plus C3, which happens to be, as you told me, negative 2/3. And style points, that guy is 2/3 square root of t cubed. And we're finished. So if you get a question and it tells you what the derivative is, but they're asking you to find the original space curve, isn't it just another reason to integrate? With the added little bonus that this piece of information that they give you, you know, R of 0 is this, R of 1 is that, whatever it might be. This extra piece of information has one job only. It allows you to find the C1, 2, and 3, the arbitrary constants. I'm seeing a lot of nods there. Would that be a sign that we are good to move on? Do you need to see another one of these, or do you feel comfortable about the process? That sounds good to me then. So show you the next guy in 10. We're going to do arc length, this top one. Don't worry about these, that's another day. We're going to do arc length. If you want to find the length of a curve in 3D space, that's basically all arc length is, right? The length of a curve. Can you imagine that this space curve, and it's not flat, right? It's coming out of the board and it's going in and it's zigging round, right? It's a 3D thing, but I'd still like to know its length. How do you find its arc length? Well, it becomes a Calc 2 integral. And it is a physical number, right? It's not a vector. This is 42, right? That piece of curved red thing is 42 inches long, right? Whatever it might be. So let's show you one in operation. Here is a, excuse me, I need to, did that go away? Hopefully I've got another one. I do. Right. So where are we? Here is an example similar to number 1. Our space curve is 5t, 3 cosine t, and 3 sine t. And t is going to go from -3 to 3. Now, this guy, and this guy, I want you to think of that's the x coordinate, that is the y coordinate, and that's z coordinate. So the arc length is going to be the integral from -3 to 3, the square root of this guy, right, dx by dt, squared, plus this guy, dy by dt, squared, plus this guy, dz by dt, squared, dt. So it's going to be the integral from -3 to 3. Differentiate this guy, you get 5, and then you square it. Differentiate this guy, you get -3 sine t, but then you square it. Differentiate this guy, you get 3 cosine, t, and then you square it. That seems pretty straightforward. Find its derivative squared, find its derivative squared, find its derivative squared, add them all together. (25), 9 sine squareds, and 9 cos squareds. I'm teaching some Calc 2 classes right now. And if you remember back to your own days in Calc 2, which might seem like years ago now, you do not like integrals with square roots. Would you agree integrals of square roots are almost always going to be bad news? So you're hoping to, whatever, that we can make it pretty. So style points is going to be your friend here. Can you see anything inside this square root that can be simplified in some way, like with a trig identity, perhaps?
The sine squared and cosine squared become 1. Or
right,
9.
and so 9 of them get you 9. Agreed?
Yep.
Right. So what does that get me? It gets me, you probably don't need this line, but think of this as notes when you go back, if you watch this video again. Now, would you agree that the square root of any number, or let's rewind that. Would you agree that the integral of any number is dead easy, right? 5 gets you 5t, 7 gets you 7t. Now, I know that's the square root of 34, but isn't the answer square root of 34t when you integrate it? Right, isn't it just a number? When you integrate any number, it's t, or in this case, t. So it's that multiple of t. From t equals -3 to t equals 3. Okay. If you plug in your numbers, you get the square root of 34 times 3. Take away the square root of 34. Oops, too many 4s. 34 times -3. 3 of these, take away 3 means add 3, so you get 6 of those. And there's your arc length. Okay. If I wanted to integrate that guy, wouldn't the answer be 3t? If I wanted to integrate that guy, wouldn't the answer be a half t? If I want to integrate that guy, won't the answer be that? And if I want to integrate e cubed, isn't the answer still just e cubed t? Do you see what I'm getting at? That if it's a number, even a weird looking number, isn't its integral just the number t? So that guy became that, because I was looking some of you and you weren't happy looking. Are you happier looking now? Right, that's all I was doing. So it's good news if you can make that square root nicer, because if you can't make it nicer, it means you are going to have to do perfect squares, U subs, God forbid, X subs. Remember X subs? Right? 30 minutes a question, right? One of those guys. You don't want those guys, right? So you're going to fight like the demon here not to get that, right? So let's look at question 2. And the space curve that we're going to deal with is 8t, t squared, and 1/12 t cubed. And the arc length is going to be from 0 to 1. So it's going to be the integral from 0 to 1. To speed things up, I am not going to write the formula again, right? I'm not going to write dx by dt squared in that. You can imagine that it's there. That's my x, right? Differentiate him, you get 8, and then you square it. Differentiate him, you get 2t, and then you square it. And differentiate him, oh, that's a quarter t squared, and then you square them. See what this ends up looking like. 64, 4t squared, and 1/16 t to the 4. Now you need style points, and you need style points desperately here. Because if I can't do something to that, aren't we pretty much scuppered? There's no way in the world I could integrate that, right? There's not a U sub in the world that's going to save me, right? It's definitely not integration by parts. There's not an X sub out there, thank goodness. Anyway, there's nothing, right? So it has to be fixable. Isn't a word, but I've created it, right? It has to be fixable. And I'm going to tell you what this guy is. I'm going to write it over here. First thing you do is write them down in order. If you ever see 3 things inside a square root, 3 different things, you are looking at a perfect square. Right? Perfect square is like, like x squared plus 6x plus 9. It means that when you factor it, you get the same 2 factors. You get what we call a perfect square, right? This is a perfect square. And I'm going to show you a little trick. The guy that goes here comes from him. And the guy that goes here comes from him. And the guy in the middle, you don't need to worry about because he'll sort himself out. So that's 64. You're going to get 8. That's 1/16 of t to the 4. Take the square root of 64. That's how you got 8. Take the square root of this guy. 1/4 t squared. That is the perfect square for this trinomial. And if you don't believe me, FOIL it out and check. It works. Is that a cool little trick? Put them in order. The square root of the first guy goes here. The square root of everybody and the last guy goes here. That will be a perfect square. Which means I can now return to my question. And it now becomes the integral from 0 to 1, the square root of 1/4 t squared plus 8 all squared. Can you see why a perfect square is such a cool thing in this question? Because the square and the square root will annihilate each other. And now we are just left with 1/4 t squared plus 8. And I don't think anybody has a problem integrating that guy, right? That's power rule, really. So add 1 to the power, divide by the new power. The 8 gets you 8t, and you evaluate it from 0 to 1. If you plug in 1, you get a 12, 112 plus 8. Take away a whole load of zeros. That's 80, 96, so 97 twelfths. So far, do you like arc lengths? Because they're basically a plug and chug kind of formula, and they end up looking like Calc 2 integrals. Okay, you got algebra to deal with, especially that perfect square. That's kind of cool. But, you know, different questions generate different situations. Yeah, let's try this one. The space curve is square root of 2t, a bit messy looking, e to the t, e to the negative t, and it's going to be from 0 to 5. So the arc length is the integral from 0 to 5, the square root of, okay. If you integrate the square root of 2t, isn't that just a power rule with an ugly constant? So you add 1 to the power and divide by the new power. So you end up with that guy.
Don't we take the derivative of that one?
Oh, yeah. Did you all catch that deliberate mistake? Kathy, did you catch that deliberate mistake?
I'm the one that asked.
Oh, God. I'm glad I've got students who know what the heck they're doing. Okay. But I have said this before. Have your differentiation cap on and then have your integration cap. Evidently, I forgot to change caps. That's what my problem was. Now, this one I will now get correct because even if I screwed it up, wouldn't I still have the same answer? Not so much for the last one, but almost. Well, actually, now I think about it, even if I screwed up the last one, it still would have been the same answer. So now we're going to do this fella. Now this guy gets you 2. E to the power of t squared isn't e to the t squared, doesn't it? Just e to the 2t. And the other one is going to be e to the negative 2t dt, and everything is inside the big square root. Now, do you see that this has got 3 terms? And I said to you, if you see 3 terms, it's going to have to be a perfect square. Because if it's not a perfect square, this question's dead. You can't do it, right? So we have to make assumption that the question is doable. Now, you write them in order. It's easy to do t to the 4, t squared, numbers, right? It's still in order. Does that make sense that this is the natural order for this particular combination? Right. If you're thinking about order, I'm really kind of talking about biggest, middle, smallest. So pick a really huge number like 20. E to the 20 is huge. 2 is in the middle. And isn't e to the power of minus 20 almost nothing, right? It's tiny. So now that I've got that, let's see if we can figure out who the perfect square is. Don't you take the first guy and find his square root, and you take the last guy and you find his square root. Okay, what's I'll write it down. What's the square root of e to the power of 2t. Or another way of thinking that is, what's the half power of e to the 2t? Because it's the same thing as the square root. So what does this guy get you?
E to the t.
Great. And won't this guy get you e to the negative t? And FOIL it out and check, it works. Are you comfortable with my little magic thing? My little trick for making things perfect squares? Put them in order, square root of the first guy, square root of the last guy, the middle guy sorts itself out. But go with that. Okay, imagine I had e to the 6t plus 2 e to the negative 6t, right? I guess it could happen. Right? Imagine I had that. It would be a perfect square. What would you get from e to the 6t?
E to the 3t.
Great. And e to the negative 3t, you'd get that. Okay. Suppose I had t to the 10, I have no idea what the number is, I'll pretend it's 2, and t to the negative 6. Pretty sure that middle term won't be that, but whatever. Wouldn't you get a t to the 5 and a t to the negative 3? Right. Suppose this was 4, wouldn't you get a 2 there? Suppose this was 9, wouldn't you get a 3 there? Do you see what I'm doing? I'm taking the first guy and square rooting it, and the last guy and square rooting it. And as long as you put them in order, you'll be fine. Order means the thing that's going to give you the biggest answer goes first, and the term that's going to give you the smaller of the 3 answers goes last. Oh, hasn't happened yet, but it could happen. Just in case, suppose that middle was -2 instead of +2, because sometimes you get negative things as well as positive things. If this had been -2, what change would I have made to this?
The sign between them would be negative.
Correct. So keep an eye open for the middle term. Although the value doesn't matter. If it's plus or minus, it does. If it's plus, this guy will probably be plus. If this is negative, this guy will probably be negative. That's maybe the only part where it interferes. Now, before I forget to finish this question, doesn't the square root of a square cancel out? Which is the whole point of this process. And now we are left with this fella. Okay, e to the t minus t evaluated at 0 and at 5. That's going to be e to the 5, take away e to the -5, take away e to the 0 minus essentially e to the 0, so that's cancelled out. And your answer would be that guy. Or if you're a purist, oops, what did that? Yeah, that minus is there. That's what I was trying to write down. We cool with that one? Not going to do that one. That's pretty obvious. Next one, no, I'll keep that for talking to myself here. Keep that one for tomorrow. Don't want that fella. Darn it. I saw one earlier I wanted to do, but darn it if I can find it now. If you hold on a second while I do a quick scroll, maybe it's at the bottom and I just missed it. Okay, I'm wrong. Our last, our last question for today, because this is quite involved, is that we're going to first have to find the curve C. and you're told that it's the intersection of two surfaces. There's a guy that looks like that, which they tell me is a parabolic cylinder, and another guy who looks like that, and they tell me that's a plane. And they want us to find the arc length from the origin to the point 5, 25 over 2, 125 over 6. So can you imagine you've got a surface, maybe it's a hill, and in that surface you cut through with some sloping line, you probably get some elliptical looking shape, right? So your curve looks like an ellipse, and you're only, imagine, pretending it's that ellipse, right? And you're taking it from the origin, which is here, to say that point there. Right, so that's like O and that's like P. And we're being asked to find that. And that's a pretty major issue because there's a lot of missing information here. The most important thing that I need to go hunting for is, don't I need to know what the curve of intersection of these two planes are? Because these are not lines, these are surfaces, right? Like a hill and like a flat piece of paper cutting it at an edge. So I'm going to rewrite the two guys again. I'm writing that one first. One of these two equations has to have only two variables in it, guaranteed, or you won't be able to do what I'm about to do, right? One of them has to have two variables. This one has three variables in it, so I don't want that guy yet. The one that's got two variables, typically one of them is going to be easier to turn into t than the other. So I am going to call this guy x. I'm going to call him t. And won't y, because he is x squared, won't he be t squared? So do you see I've already got some in my space curve. Instead of x, I have this. Instead of y, I have that. And then I go to this equation. And I know who x is, and I know who y is. And then I can solve for z. Are you comfortable about how we found the parametric equation of the line of intersection of those two planes? You pick the one that's got two variables, and then typically you choose one of them to be t. If you've got a choice, I'd pick x equals t if it's a possible choice, right? Pick that. And then the other one will be, in this case, t squared. And then you can go to the one that's got, you know, the three variables in it, whatever, and you should be able to get that, yeah. So that's part one done. I've got my fella. I still need to know where t starts and where t finishes. Great. And the question says, from the origin to this ugly guy, what value of t will this guy be, and what value of t will that guy be? That's essentially what we're dealing with, right? Here's the clue. Isn't the x coordinate also the t value? Isn't x equal to t? So won't this be from 0 to 5? And I think, yeah. It has no effect on the answer, by the way, but the y and z coordinates were wrong. That means I've got everything I need then. I got a space curve, I got a start and a finish. So my arc length will be the integral from 0 to 5, the square root of the derivative of this guy squared, the derivative of this guy squared and the derivative of this guy squared. And this becomes there's a kind of theme that's happening a lot right now. If you put this fella in order, from biggest to smallest, powers are easy to do. Do you recognize that form? Because this isn't a perfect square. Okay, I need a perfect square. What's this guy going to get me?
T squared plus 1.
Do you know if you FOIL that out in your head, doesn't it work? You could probably do that in your head. You see it working. So it's not just you do it, but it doesn't really work. But you just, it works, right? It works. So that means I've now got the integral from 0 to 5 of just t squared plus 1, which nobody here, I'm sure, would complain about, right? That's a very easy integral.
Quick question.
Yes,
I'm sorry, could we FOIL that out real quick? Just
sure.
for my brain to see it.
T squared plus 1.
That doesn't work.
Wait. Where did my 2t come from? Have I screwed up with the 2t?
Should be 2t to the 4th.
Hey, it doesn't, does it?
Or 4th t to the 4th. wouldn't it?
Oh, shit. It would have worked if I'd written the darn question down correctly. The question is x squared equals 2y. Okay. Can we pretend it did work? Because I don't want to do this question all the way through. Oh, shooting space. I apologize. Because that will make this fella in the middle the right amount. Right. It will make this guy here a 2, because that'll be a square root of 2. Yeah. And that'll be a 2, and it'll work. Can you trust me that that becomes a square root of 2? Because you're going to have to take this fella, and that's going to make y equal essentially a half x squared. So that makes y equal 1/2. Oh, it may not be 2. It'll be that guy, which makes just y equal to t. No, okay. Remind me tomorrow to do question 5 again. Right, and we'll just do it, because I'm not sure my square root of 2 fixes it. I know it works. I should be able to check the solution here right now. If you give me a few seconds, just to make me feel good. All right, here we go. Yeah, it works. Yeah, that 2 made all the difference, right? It does work. So, sorry about it. Okay, everyone say hi. We'll finish off today. And I'll see you all tomorrow. I'll hang about for homework questions. I wish that last question had worked. It would have been nice to just finish on a smooth one, but you know me, scanning's not my great point. A little 2 could make a big difference to a question. Okay, who wants to start? Arvin, do you have a question for me? Oh, she's gone. Anybody, any of you 3 guys got a question?
Yeah,
Yes.
I have a quick one. Oh,
Yes.
go ahead, James.
Oh, you go ahead. I thought you were just a spectator.
Oh, yeah, I usually am, but so for the one that we just did, So like
Yes.
so what we're doing is we're finding the space curve, we're finding the limits, or
The T start and finish.
yes,
Yeah.
exactly, the start and finish, and then we have the point, so then we just plug it into the equation that we've been using to find the arc length, and then
Yeah.
we'll find the arc length from there.
Yeah, and tomorrow when I do it with x squared equals 2y, you'll see it working perfectly.
Okay, it was just a
It was just
number,
an oops
yeah.
of missing out a 2.
Okay.
And because of that, I didn't even bother checking the middle term because I'm assuming that it was a perfect square, because it will be when I do it the next time. But the middle
Yeah.
term sorts itself out. But evidently, well, I mean, if you don't write the correct question down, don't be surprised if you don't get the correct answer. Any other questions? Okay, so remind me, because you know what my brain is like, we are going to do question 5 again, but correctly, right, so that we can get that done.
And I do have a question.
Oh, good. What you got?
So it's, do you have time to talk about the test 3?
Sure. What do you want?
Okay, so here, do you want me just to tell you what the problem was so we can work through it?
Sure. That'll work.
Okay, so there's 3 in total, but this one is find the lengths of the sides of the triangle PQ and R with points 3, -2, comma 0.
Mhm.
And then point Q is 7, 0, 4.
Right.
And point R is 9, -4, 0.
Okay, let's put that on. It might already be on. Right.
Cool.
So, making no attempt to be realistic, just something to visualize. There's a PQR, right? And the question was asking for the lengths of them. Is that right?
Yes. And I was able to get the lengths right.
Okay,
And I
so
know that it's a right triangle. I just apparently got it wrong when it asked me, is it an isosceles triangle? I said
okay.
it wasn't.
Okay, so what? Tell me what PQ. I'm assuming you called them something like PQ, PR, and maybe QR. But just tell me what the 3 lengths are that you
So
got correct.
PQ is 6, QR is 6, and RP is 2 square root 10.
Say again. 2 square root of 10.
Yes.
Well, that's going to be. That's not going to be a right angle triangle, then, is it?
Oh, no, it isn't. I'm sorry, I hit no.
Okay, but no is good. That's the correct thing to say. If 2 sides are the same, isn't it isosceles?
Oh, I think I mixed it up with equilateral triangle.
Oh, equilateral would be 3 of them the same.
Yeah.
Oh, that's
So
all it was.
could you remind me what exactly makes an isosceles triangle?
An isosceles triangle is any triangle where 2 sides are the same length.
Ah, okay.
So it's a pretty easy hurdle for a triangle to jump, right? Just have 2 sides the same length in your isosceles. It's much a harder hurdle to be right angled, right? Because to be right angled, the biggest one squared has to be equal to the 2 smaller ones squared and added. And to be equilateral is very hard, because the only way you can be equilateral is when all 3 sides are the same, right? And it's a pretty high hurdle for a triangle. The easiest triangle in the world is called a scalene triangle. And a scalene triangle is just a triangle where all 3 sides are different. There's nothing special going on. So pretty much every triangle in the world virtually could be called scalene.
Okay.
Cool. But if you want to be lawyer-esque, they have to be 3 different numbers.
Okay. So
okay,
that's no problem.
That's that one. Right, next one.
Let's see, number 3. So we have find the angle between the vectors.
Okay.
Find an exact expression, then approximate to the nearest degree. Okay.
Okay.
So I got the approximation right. I got the exact expression wrong. So
Right.
vector,
In the exact expression, did you put this fella in?
let me,
I'm making up numbers, but let's suppose the answer ended up being that, right? Did you put the inverse cosine thing in, or did you just put in that?
I put in -15. Let me look where that came from.
I don't know where that came from either, because that wouldn't be a valid answer in the context
You're
of this
talking
question.
about, Sam, you're talking about your approximate answer, right? Not your exact. Because you
I'm
got your
talking
exact
about I got my approximate right. My exact answer is the -15 that I put in. I'm looking at my work right now, and
The reason I'm saying that I'm worried about -15 is that nowhere in the equation of calculating cosine of theta do you have negative things of any kind. Well, I'll rewind that. You could have a negative dot product, but you'll never get a negative that's bigger than 1, right? You won't get a -15. You won't even get a -2 because the values always go between -1 and +1. You know, actually for the cosine at least, -1 to +1.
okay, I see what I did wrong, and I have no clue why I did this, but I got the -15 from the dot product. That's the dot product.
Well, okay, that is fine, but doesn't the dot product then have to get
Yeah,
divided by those two guys? So you just forgot to put those two guys in?
well, like, I did all the work completely right, but when I plugged it in, I must have glanced at my work wrong and just seen -15 up near the top.
So like today I scanned and missed the 2, you
Yeah.
scanned and missed the bottom.
That's my best guess, but I have all the work there, so. And you gave me some points back, so I'm guessing that's where the points came
That's
from.
where they got them from, probably. Yeah.
So, and then there's one more, and it's find the volume of the parallelepiped
I like that question. Right. Anyway, go for it.
with adjacent edges PQ, PR, and PS.
Uh-huh.
Point P is -2, 1, 0.
Right.
Q is 4, 5, 4.
Okay.
R is 1, 4, -1.
Okay.
And S is 3, 6, 2.
Okay, so this is going to be a little bit messier. So let me imagine that this is P, this is Q, this is R, but I'm going to go this way. And then I'll put S up here, like this. So can you see the parallelepiped shape?
Yes.
Right. So what I really need to get here is what's called sometimes called a triple product, right? It's a cross product dot with someone else. So as I look at this, the vectors that I'm interested in are PQ, PR, and PS, and I've decided to focus on that corner with the 3 guys leaving it.
That's what I did as well.
Right, now it doesn't matter which one you cross product dot product with, right? Because the only difference will be that sometimes your answer is negative and sometimes it's the same number but positive. And since this is a volume, you always remember to stick an absolute value around it when you're finished so that you get a positive answer no matter what happens. So if I look at PQ, 4 take away that guy is 6, 5 take away that guy is 4, and 4 take away that guy is 4. Did you get that for PQ?
Yes.
Okay, so the next guy I'm going to get is PR, and 1 take away that guy gets me 3, 4 take away that guy gets me 3, and -1 take away that guy gets me -1, so that's PR.
Yes.
And the last guy I need to find is PS. And so 3 take away that guy gets me 5, 6 take away that guy gets me 5, and 2 take away that guy gets me 2. So far, so good?
Yes.
So I'm going to do the cross product of the first two. That's a cross product of the first two things. Dot product with the third one. So I've decided to go that route, although
Yes.
any other combination will work. So I'm focusing on this. So it's going to be I, J, K. And we are looking at 6 and 2 4s and 2 3s and a -1. Agreed?
Yes.
And so it's so many I's, take away so many J's, plus so many K's. Right, if I cover this guy up, it's -4 take away 12, which I believe is -16. If you cover up the middle guy, it's -6 take away 12, which is -16. And if I go for the third guy, it's 18 take away 12, which I believe is 6. So that becomes -16, +16, 6. Does that look good?
Could you do J again? I think it's
Right.
-18.
Okay, let's check it. -18 it is, which makes this +18. We agree now?
Yes, that's what I got.
Okay. Now, this guy, dot, right, the dot product with PS, which is this guy. So we're going to get -16 multiplied by 5, added to 18 times 5, added to 6 times 2. That guy's -80. That guy is +90. And this guy is 12. So it looks like I got 22.
Yeah, that was where I got it wrong. So instead of -16 times 5 equaling -80, I got -40. So that was where I got it wrong.
Yeah. I can imagine how frustrating that should be, but really, you know how to do it, right?
Yeah.
Your mistake was not on concept or application. It
Yeah.
was just being careful, right? It was just doing a little calculation and not doing it right.
Yeah, I'd rather my mistake be something like that than not understanding the concept.
Yeah. So you did it bang on, right? So
Cool. Thank
Cool.
you. That was the last question.
okay. Usual, although I've got a blanket coverage, didn't we, from last time? So it's okay for me to use it. We do it the other way around. You opt out. So if there's ever a video where you think, no, I don't want people to see what I just screwed up there. But you're helping people because they will screw up in the same kind of places. So it's nice for them to say, oh yeah, I got to be careful about my signs. And so they're learning to. But if you feel something's sensitive or you don't want, you have total power. You just say, don't use that and I'll cut it out of the video. Okay, any other questions for me? And call it a day.
So yes, I have a question
Yeah, Josh.
from 13.1.
Is it easy to write down? Says we can go hunting for it.
It's question 14. I don't need the whole problem solved.
Okay.
It's just that I went back and looked at my notes from the lesson, and I don't know what I was doing. Must have been half asleep.
So your question is?
Two parallel lines traveling along the space curve. The first one would be t squared, and t cubed. And then the second one would be 1 plus 4t, 1 plus 16t, 1 plus 52t.
Are they wanting the point of intersection if it exists, or
Yeah.
what are they looking for? Point of intersection. Okay. So actually, this one is a line, but this one here is some kind of curve, and it might intersect here and or here, or it could be flying above it, right? Are these both in T's? Is one T and one S, or are they both T's? That's kind of
They're
important.
both T's.
Okay, so they can intersect or they can cross over, which might sound like I'm saying the same thing, but they have a specific thing. Can you imagine at this point here, the curved guy gets to this point here when t equals 5, but the straight line doesn't get to here until t equals 10. So they do cross paths, but they don't crash into each other. But at this point here, if t was 3 in both cases, wouldn't the aircraft smash into each other? If you imagine these are two aircraft traveling. So this is an intersection, and this is I guess I'll call it a crossover. Did they use any of those terminologies in this question?
Just find the points at the path of their intersection.
Okay, so if you look at the two x's, they're going to have to meet, which is at t equals -1/3. Now, if that's going to happen, then this will have to equal that at t equals -1/3, and this will have to equal that at -1/3. So I can tell you right now that is not going to happen. So these two don't intersect. Is not intersecting an option?
Yeah, it is.
So they don't intersect.
Okay. Because I talked to my brother and he was like trying to graph it, and their intersection points
Well,
were.
yeah, if you do it in some of the software, you should be able to rotate it and see. It looks like, I'm trying to do with my fingers here, it looks like they're crossing, right? But when you turn sideways, you see that they're missing each other. Right.
Yeah.
An intersection would be a physical, you know,
Mhm.
sharing a common point would be an intersection. Right. So are you okay with the fact that when I got this number, I know by checking in the Y's that they don't match and the Z's? Now, let's pretend just for argument's sake that this was an intersection. Then when I plugged it in here and here, the Y's would be the same number. And when I plugged it in here and here, the t value, the z's would be the same number. And that would be the point of intersection.
Yeah.
Right. That's it.
I guess I thought it had to be harder.
Oh, you overthought.
I was like, they had to
Yeah.
intersect. It doesn't
Because
like it.
you just wanted them to intersect, so you were going to make it happen regardless.
Yeah, well, I graphed it and my tricky software made it look like they crossed at, I think, 1
Ooh.
and 8.
At 1 and 8. Well, 1 works. 1 doesn't work. Yeah, 1 doesn't work even. 8?
Well, it actually says that does not exist is the wrong answer.
Okay, let me look at 13.1 because there might be something in the phrasing that gives me a clue.
So it'd be the point, find the points at which their paths intersect.
Intersect or cross. Well, okay. So they're allowing them to reach that point at different times. That sounds like what they're saying. Then that does change the question quite a bit. Right, I'm looking at 13.1, question 14. But if they were doing that, they should have used different letters because that would have made me. Yeah, they didn't, the little darlings. Okay. So that is going to be a little bit trickier.
So the second variable is actually like S instead of T or something.
Yeah, that's essentially what they should have done here. Because remember my story where this guy reached it at the 5-second mark, but the other guy didn't reach it to the 10-second mark? That's what they're after. But if you're going to do that, you need to have 2 different variable labels. Otherwise, I think you're going to have a big problem matching them up. Okay, so that's me changed the question so that one of them now has a S and the other stays as a T. So let's look at how we would find this place. So you could get, you know, like this here, right? At T equals 5, but I'm going to now say at S equals 10, right? So I will match up the X's, call that equation 1. I will then match up the Y's, and I will call that equation 2. And I will lastly match up the Z's, and I'll call that equation 3. So essentially, I've got systems of equations that I'm trying to solve for S and T, right? I'm trying to find a combination of an S number and a T number where these three things are true. So if I take equation 1 and 2 and just use those, if T is 1 plus 4S and you replace, or substitute would be another word for that, into equation 2, which is this guy, let's see what you get. Instead of T squared, you get that guy squared. And 1 plus 16S. Are you happy about using that guy to go there? Now, if you FOIL this out, you'll get 16S squared, 8S plus 1. And that's going to be 1 plus 16S. If you subtract 16S from both sides and you subtract 1 from both sides, you get that. If you pull out 8 as a common factor, you get 2S, take away 1, and you have got some candidates. One of the candidates is S equals 0, and the other candidate will be S equals a half. And I'm just calling them candidates right now because I have to check with equation 3 that they match up. All right. So when S is equal to 0, T will be 1 plus that. So T will be 1. So that's one pairing I need to check. When S is a half, if you plug it in here, T equals 3. So that's another matchup that I need to do. And let's test it against 3. 3 says that T cubed has to be 1 plus 52S. If you use this combination here, is 1 cubed 1 plus 52 times 0? Yep, it is. So that works. So when S is equal to 0 and T equals 1, we have a match. Okay, let's try the second one. T cubed needs to be 1 plus 52S. When T is 3, you get 3 cubed, and it has to be 152 times a half. That's 27, and we get a match. So it also works. So S equals a half and T equals 3 works. Right, now that I have got 2 matches, let's find out what those points are. If you do the first fella, which is T squared, T cubed, T equals 1 works. So that makes the point 1, 1, 1 work. If we do the other one, which is 1 plus 4S, 1 plus 16S, and 1 plus 52S. If you do that one and you plug in a half, you get 3, 9, 27. And that one also works. So there's your 2 points. Now you might want to plug them in as coordinates 1, 1, 1 and 3, 9, 7. check them out. They look too nice to be wrong.
So when you found S, you solved for T just by plugging it back into like any of the equations?
Yeah,
Okay.
yes. James, are you able to put in those two answers just to verify that they look good?
I'm checking it out.
So I think you put the one with the smaller X in the first box and the 3, 9, 27, the bigger X in the second box.
Yeah, it liked it.
Right. Me personally, I blame WebAssign. If they had said R1 of T and R2 of S, that would have made a lot more sense to me, because intersecting when you make them both T means that those two aircraft have to crash into each other. These 2 points don't mean that. That just means one flies over or through the other point, but the other aircraft isn't there anymore, right? It's traveled on and it's somewhere else. So I blame WebAssign for most of the confusion there. They could have phrased it better, and they could have written down the information better.
Yeah.
So I'm not surprised you had problems with it. So did I.
Okay, I think that's all the problems I have.
Okay, we call it good then, guys. We finished for today.
Yep.
Right, I will see you all tomorrow, where we get to do some heavy duty. Well, we're still getting arc length, but after arc length, there's some heavy duty math going on. So that'll get your brain moving.